Hello guys, welcome to another interesting video in the series of coding. It's called Validate Binary Search Tree. So you are given the root of a binary tree to determine if it is a valid binary search tree or not, and the following rules are given for it to be a valid binary search tree. The left subtree of a node contains only nodes with keys less than the node's key, and the right subtree of a node contains only nodes with keys greater than the node's key. Both the left and right subtrees must also be binary search trees. So let's understand this with the help of two examples which they have given. So in the first example, 2 is a root node, 1 is to the left of it, 3 is to the right of it. Now 1 is smaller than 2 and 3 is larger than 2. So this is a valid binary search tree and we can return true. Moving on to the next example. So 5 is the root node. Considering 1 which is left to 5, 1 is smaller than 5, so this is fine. Now moving this side, 4 is the right node of 5 and 4 is smaller than 5, but 4 should actually be greater than 5 for it to be a valid binary search tree, because all the nodes which are to the right of the root node should have values greater than the root node. So this condition is not being satisfied, so it's not a valid binary search tree. Okay, in this case, even if this condition was getting satisfied, even if 4 instead of 4 some other value that is greater than 5 would have been here, then also this is not a valid binary search tree, because see here, 3 is a part of 5's right side, so 3 is not greater than 5, 3 is still smaller than 5, so still it would not have been a valid binary search tree. So all the nodes that are part of right side of the root node should be having values greater than the root node, and all the nodes that are smaller than are in the left side should have values that are smaller than the root node. So this is the condition. So let's try to understand this with the help of some diagrams. So I will take some examples. Suppose this was my binary search tree, 5 3 1 4, and suppose it had children 2 and 6, and then to the right of 5, suppose we had 8, and here we had say 3, and here we had 10. Okay, suppose this was my binary search tree, so I'll check if it's a valid binary search tree or not. So let's see how we'll solve this problem. So initially I will give my conditions. So this color is not dark enough, I'll take some other color. I'm going to pick this color. Okay, so initially we will check the condition whether this lies between minus infinity and infinity or not. So this is going to be my min and this is going to be my max. Now my phi is satisfying this condition. Okay, now we'll go on to the next value. So for 3, now the condition will change. The condition of min and max values that it should lie within will change. Okay, so for 3 the condition to check will be, see, 3 is to the left of 5, right? So all the values to the left of 5 should be smaller than 5. So the max value will change and max value will become 5. Min will remain same, the minimum value will remain same, max value will change. Now we should check if 3 is going to satisfy this condition. That is, if 3 is going to lie between minus infinity or 5 or not. If it is lying outside these bonds, then we can return false. But it's lying within these bounds. So 3 lies between minus infinity and 5, which are the minimum and maximum value conditions. So this is fine. Now we will go to the next left node of 3. So now whichever node is left of 3 should satisfy the condition that it should be less than 3. So the minimum and maximum values that we should check will be minus infinity and 3 will be the maximum value. Now 1 is between minus infinity and 3, so 1 will return true to the function call. Okay, now we can check to the right of 3. Now for the right of 3, what will happen is the minimum condition will get changed. Minimum condition will get changed to 3, because right of 3 all the nodes should be at least greater than 3, and the maximum condition will remain same. So the maximum condition was anyway 5, so that will remain same. So now 4 is lying between 3 and 5, so this is fine. Okay, this is fine. So now 4 will go and check its children if they are also fine or not. Now for its left child, for the left child of 4, the condition to check will be, so again the maximum condition will get changed. Maximum condition will be changed to 4, that is, all the nodes which are to the left of 4 should be at least smaller than 4, but the minimum condition will remain same, which is 3. Okay, so we have to check if 2 is within 3 and 4 or not. So no, 2 is not within the limits of 3 and 4, so this is not true, so it will return false. Okay, and we will move forward. Now for 6 we will have to check the condition. So for the right node of 4, the condition to check will be, see, it's a right node of 4, that means all the values should be at least greater than 4. So the minimum condition will get changed to 4, the maximum condition will remain the same. So we should check if this is between 4 and 5 or not. So it is not between 4 and 5 because it's outside these bonds. So this is also not true, so this will also return false. So both are returning false, and hence 4 will also return false. So now true and false that combined will return false, and of true and false will return false. Okay, now we will move forward to the right side of 5. So for it, bounds will be, it's right side of 5, right? So all the nodes that are to the right of 5 will have to check the minimum condition that they should be greater than 5, and the maximum condition will remain infinity. So we'll check if 8 is within 5 and infinity or not. So that is fine. So now it will go and check on its children. So for it, the condition will be, so before that I will make some space for checking the condition of it. Okay, so for it, the condition will be, see, it is to the left side of 8, right? So since it is to the left side of 8, that means it should be smaller than 8. So the maximum condition will get changed, but the minimum condition will remain same. So the node should have value between 5 and 8, but it is 3. 3 is out of bounds, right? So in this case it is not true, so it will return false. Now we will check the condition for 10. So the condition for 10 will be, see, it is to the right side of 8. So the bounds that will be there will be, it should be greater than 8, right? That is the only bound that it will have, and the maximum bound will remain same, which is infinity. So from 10 side, it is satisfying this condition, so this will return true. So 8 is getting false and true, it will do the and of both and it will return false. So it will return false to this function call. Finally false and false will return back false to the output. So this is just a random example I've taken to try to explain. So let's start coding it. So we will have to declare another function. So let me declare the function return, and I can call it anything. I'll call it small bst for binary search tree, and I will have to pass my root to that function. Okay, and I will have to pass minus infinity and infinity initially. So instead of that, I'll just pass the long minimum and long maximum value, so they'll be very small and very high values anyway. So and then we will have to declare boolean bst function, and it is going to accept the parameter of node. So bst tree, I will just zoom it a little bit more so that it becomes more clear. Okay, so tree node star root, and as well as it's going to accept long int min and long int max. So why I'm making them long is because in one of the test cases of Leetcode, they have taken a extreme value of the long int. That's why we have to take this condition, else all our test cases will not pass. So we are taking long. Okay, and let's move forward. So what we have to do is, first, if root is becoming null, in that case we can simply return back. Okay, otherwise what we can do is we can move forward and we can check the conditions. So if our roots val is out of bounds, that is, if either it is, see, it should lie between minimum and max, right? So it should be between the bounds of minimum and max. So if it is either smaller than minimum or it is, say, larger than max, so in that case it is going to give us problems. So if this condition is true, then we can return false. Okay, otherwise we have to check its children. So we will have to check its left and right nodes. So otherwise let's check. So we can do return of, so we will have to pass roots left first. Okay, so we'll have to call this function recursively. So return bst of root left, and while we are traversing the left side of the nodes, so what will happen is the condition will be there that left side of the nodes should be smaller than the root node. So if they should be smaller, there will be a limit on the max value and the min value will remain same. So the limit on the max value will that be that they should be smaller than the current roots value. Okay, and along with this we will have to return the condition of passing Okay, it's right side, so we are going to traverse roots left as well as right. So in this case, the minimum value will change. Okay, so because the condition will be that the minimum value should at least be the roots current roots value, and the maximum value will remain same. So this should be it, and we will have to return the and of both of them. So this should work. Let's run and see if there are any issues with this. So there is a compile error. They have expected us to close the function which we have not done. So we have not closed the class actually. So let's close it now. There is still a compile error. BST should return. Okay, so it should return. So we forgot to put true here. So if root is null, it should return true, right? It reaches the end, and in that case, it will be true. So it is finished and it's passing the first test case. Let's see if it's passing the other test cases also. So yes, it is a accepted solution. Thank you.